Lesson 823, problem 879. In this problem, we're given quadratics in different forms. So we need to first verify that this is in fact a quadratic equation by rewriting it in standard form. Remembering standard form is y equals ax squared plus bx plus c. So here's the first problem we're given. And we're going to go ahead and try to rewrite this so that it's in standard form, so we can verify that it is a quadratic equation. So the first thing I'm going to do is I want to follow my order of operations. And so I have multiplication, exponents, some parentheses, and a subtraction here. So the first piece I'm going to do is that exponents, because there's nothing I can do inside of the parentheses right now. So I have x minus 2 squared. So that's x minus 2 times x minus 2. Okay, if I rewrite that part out. So then, to take care of this piece, I need to go ahead and put it in a generic rectangle and a diamond to rewrite that. So I'm going to do that. Oh, I should just say a generic rectangle here. No diamond. So here I have x times x, that gives me x squared. X times negative 2 gives me negative 2x. And then x times negative 2 again, negative 2x. And then negative 2 times negative 2 gives me positive 4. So rewriting that piece, I have x squared minus 4x plus 4. And that was just this piece here that I have underlined. So out front, I still have this 3, and I still have this minus 5 at the end. Okay, now the next thing I need to do is multiplication. So I need to distribute this 3 to all of the terms inside of my parentheses. So this becomes y equals 3x squared. And then I have 3 times negative 4x, which gives me negative 12x. And 3 times positive 4 gives me positive 12. And then I've got to bring down these minus 5 right there. Okay, and then I'm just going to go ahead and keep working and combine these like terms. So I end up getting y equals 3x squared minus 12x plus 7. So now looking at this, I do agree that it's a quadratic equation. I've got my ax squared term, my bx term, and my 1's. So now what I'm going to do is I'm going to go ahead and I'm going to graph both this equation that we got after we went through and rearranged it and my original equation. So I'm going to go ahead and get into my Desmos calculator. And I'm going to go ahead and put that first equation we were given. So y equals 3 times the quantity x minus 2 squared, and then we have a minus 5. All right, so we can see that one there in red. And I'm going to put the one we got after we rewrote this. So it should look the same because all we did was rearrange things. So when we rewrote this, we've got y equals 3x squared minus 12x plus 7. All right, so that was the blue one. My original one was my red one. You can look, they're overlapping, okay? So they are in fact the same, they were just written in different forms. So then the question is going to ask us to find the vertex on the graph. So remember, the vertex is it's either your minimum point on your parabola or your maximum point. So it's right here. So the vertex here is 2, negative 5. And if I were to look at my red graph, it is the same point, 2, negative 5. Okay. So I'm going to go ahead and go back to my other page here and write down what we got for the vertex. So the vertex for this was 2, -5. And just to rewrite what our original equation was, y equals 3 times x minus 2 squared minus 5. All right, I'm going to highlight these pieces because I want to come back to this a little bit later. Okay. All right, let's take a look at the next one. Try this again. So now we get f of x, which is just another way of writing y, equals 2 times x plus 4 squared plus 3. Okay, so we could go ahead and work through this again, get it into standard form, make sure it's a quadratic, and then after that we want to go ahead and take a look at the graph of this and the vertex. So I'm going to go and put this into my graph, my Desmos calculator. Alright, so this equation was y equals 2 times the quantity x plus 4 squared plus 3. Alright, so we can see it there in green, and I'm going to take a look at the vertex. So the vertex for this quadratic equation is -4, 3. I'll go back over and write that down. So the vertex on this one is -4, 3. And I'm going to go ahead and highlight that too. Okay, and so now what I'm wondering if you see any connection between the equation and the vertex. So I'm going to just kind of point out some things that I notice here. I notice that the y-coordinate of my vertex, so this piece here, is the exact same as this number at the end of my equation. So that same thing is happening in my second one here. This +3 is my y-coordinate of my vertex. And then I take a look and I'm noticing that the x-coordinate of my vertex is the opposites of what I have inside of my parentheses there. And that same thing is happening here. This is a +4 and this is a -4. So I'm seeing a pattern when I have my equations written in this form. I'm noticing that I can see my vertex right away. So without graphing, I'm going to go ahead and do one more here and see if we can find the vertex quickly. So we're going to look at y equals 1/2 times the quantity x plus 3 squared plus 2. So using this pattern that I saw above, the y-coordinate of my vertex should be the same as this number hanging off the end of this equation. And the x-coordinate of my vertex should be the opposite of what I'm seeing in here. So it's a +3, so I think it's -3. So I'm going to go ahead and graph this now and double check that I in fact have my vertex at -3 too. Go back in, type this in, y equals 1/2, go just put 0.5 times x plus 3 squared plus 2. All right, I'm going to go ahead and click on that, and I do in fact see that my vertex is at -3, 2, which is what we thought it would be. All right, so there you can see a shortcut to getting your vertex when you have your equation in this form.